Hello YouTube, Rick Wilson here. Hey, this video is going to be a little different. It's about time and space-time, and I've got some new ideas. I think the old ideas are bunk, and this happened because of watching the movie Interstellar. And in the movie they go to these 3 different planets, but one of the planets is near a black hole, and in the movie the gravity from the black hole was so intense that time on this planet, for each hour that the astronauts spent on the planet, the astronauts who were orbiting the planet, 7 years went by. So the people on the planet, 1 hour went by. The people up in the spaceship orbiting the planet, 7 years went by for each hour that the astronauts on the planet experienced. And I know that this is possible. Science has proven the time differences throughout the universe, but I don't think it works the way they're saying it works. And so I've been thinking about it hard for a couple weeks now. That's why I haven't been making no videos. I've been really, well, and I hurt my back. I've had to be going through physical therapy, and I had some teeth pulled, and I'm in the middle of that still. But still, I figured out a new idea on time, space-time, and that's what this video is about. So if you like things that bend your mind, hang in for this video. It's going to be good. If you want to see some new ideas about space-time, hang in. The video will be good. If you want to blast my ass down below that I'm full of shit at the end of the video, hang in. The video will be good. So anyway, here's the conventional view of space-time. You always see them. They just recently found the Higgs boson over in England there with that big accelerator they got. And by proving the Higgs boson, they proved the existence of the Higgs field. Now the scientists say that the Higgs field is what gives matter its mass. Without a Higgs field, all matter would have no mass. They were saying the way particles and atoms are put together, theoretically they shouldn't have no mass, but they do. And they're saying that now they discovered this Higgs field. It's an energy field, and it's all throughout the universe. And this is what gives matter its mass. And then anything with this is how they claim now. Anything with mass has gravity, and anything with gravity distorts time. And so basically they're saying that this is how things, you've seen this before, space-time. They're claiming it's a fabric. It's like a fabric. It's bendable, flexible. When you put a massive object, this is like a 2D representation. They always put the ball that's on the sheet, and it bends the sheet down, and then you roll another ball, and it'll act like it orbits that because of the way the sheet is held down in like a funnel shape. And they were saying this is how space-time and anything moving tries to follow the lines of space-time until it is bent by a massive object by gravity, and then it'll follow the lines of space-time, which will bend and possibly even bend right into the object, which is why they claim we're stuck to this planet. The problem is this is a 2D representation, and we don't live in a 2D world. We live in a 4D world. We don't even live in a 3D world. We live in a 4D world. You got width, height, depth, and time. You got time. Time's part of it. Time's part of the equation. So you got actually 4 dimensions, not just 2. And so how do you picture? That's why I've been running these, like Einstein did. I've been running these experiments in my mind, just pictures of things and how they work. And I've tried to figure out how this Higgs energy field can cause all this to come to be. Well, you got to quit looking at it like this, and you got to quit looking at space as a fabric. It's not. It's not a fabric. And they let me get a piece of paper. Just like they claim it can be bent, where they always do the wormhole thing, where space is bent like this, and then you get a wormhole, and you can cut from one part of the universe directly to the other part of the universe. No, that can't happen. It would take so much gravity to cause a wormhole that anything going near the wormhole would be destroyed, for one thing. But I don't think it's possible to have a wormhole, because I don't think space is a fabric. let me move my thing here, and I'll show you what I do believe. I believe that here's the same massive object with the Higgs field around it. The Higgs field is an energy field. It's an energy field. It's not a fabric. You can't bend it. You can't, do anything. And the Higgs field is attracted to matter. And they claim that the Higgs field is what gives matter its mass, and that the mass then causes gravity. Now, they can never be able to work gravity into anything. The theories of real Einstein, he tried for years to work gravity, and he couldn't do it. And the reason that they can't figure gravity into anything is gravity's an illusion. Gravity don't exist. What you have is the Higgs field throughout the universe, and the Higgs field is more intense anywhere it is near matter. And the more matter, the more intense the Higgs field is. And so say this is the Earth. So it's a lot of matter. It's got to really, see the Higgs field, it gets really intense around the Earth, and then less intense as you move away from the planet. And what I believe is the Higgs field itself determines the speed of time. The more intense the Higgs field, the slower time moves. As you move out into less dense areas of the Higgs field, time speeds up. And that'll cause the illusion of gravity, because if something is passing by the Earth, and this gravity, see, the gravity is most intense right at the ground and less intense out in space, or not the Higgs field. I don't know if did I say gravity? I'm not sure. But anyway, the Higgs field is less intense out of space and most intense right at the ground. It's actually most intense right inside the planet, because the Higgs field takes up the space within the atoms, all the space between the electrons and the protons and the quarks. It's all that space is filled up with the Higgs field. So the Higgs field continues right down to the center of the planet. And there is layers like an onion coming out from that of time dilation, with slower and slower time as you move toward the center of the planet, faster and faster time as you move away from the planet. Now, if something is passing by our planet coming in this direction, this object, let's just draw an object here, and it's moving in this direction past our planet. Now, what happens? You got these time differences. This side of the object, now you're talking about quintillionths of a second difference in these times. I mean, well, for example, the satellites in space that they use for your navigation system on your car, they found out they couldn't put a clock like here on Earth in those satellites, because time is moving faster in space, and so they had to put a different clock on the satellites to make up for the time difference. Because if they didn't, your navigator in your car would show a location 7 miles off from where you really are every day. It would go 7 miles further off from where you really are every single day, because of the time dilation between the surface of the planet and the satellite up in space. So they did have to build clocks that run at a different speed than the clocks here on Earth to make the navigation. So they understand time dilation. They understand that. But what they don't understand is that's what causes gravity. So what happens is time is moving faster on the outside of this object, and time is moving slower on the inside of the object, which causes the object to change direction. The object would then bend right in toward the Earth and act just like gravity. So that's what I'm saying. Gravity don't exist. Everything is time dilation. The entire every centimeter of the universe is running on a different time than the centimeter next to it. Like I said, you're talking like quintillionths of a second, but it's still time dilation, and time is what causes all these forces that we feel throughout the universe. As you accelerate toward the speed of light, you gain mass. And I believe that's because you're hitting more of this Higgs field. As you accelerate, you're hitting more and more pieces of this Higgs field as you move through it, and it kind of piles up, and time slows down around you. So that's why they're saying if you could approach the speed of light, a year would go by for you, a million years would go by here on Earth, because time would be moving slowly for you, and it's because of the Higgs field. And so that's what I said. It moving fast can change time because the Higgs field piles up in front of you. You're pushing matter through it so fast that time slows down. The same as it slows down their matter. So it's the same thing both ways, either way, whether you're accelerating or whether it's matter, it's still the Higgs field changing time. And another thing I was thinking about, I think we could still be in a closed universe. They're saying the universe either ends in the Big Crunch or the Big Rip. And right now they're saying the universe is accelerating faster and faster and probably going to end up in the Big Rip. But that's considering there's a fabric to rip. Now there ain't no fabric, so there ain't going to be no rip. Now if the universe was to just keep expanding and expanding, the Higgs field would spread out so far and become so diluted that eventually matter would fall apart when the Higgs field got weak enough. But that would take a long, and the universe would have to get really large. But I'm not so sure that that's actually happening. I think the universe may be slowing down and going to contract again. Maybe the Higgs field, since it is an energy field, maybe it's oscillating. Oh my gosh, I said oscillating. That means over and over. The universe repeats itself. So the reason they say the universe is speeding up is because they look at stars a couple billion light years away to look back in time, and they're looking back in from our time. How long did it take to light according to the time that we live in here on this planet? Now what they're getting though is light from 2 billion years ago. Now the universe has grown a lot in 2 billion years. So if you go back in time 2 billion years, the universe was a lot smaller. The Higgs field, same amount of energy, was in a smaller space. Time moves slower for the entire universe 2 billion years ago because the Higgs field was more intense. And so we're looking at light from a universe where time was moving much slower. So it appears to us, when we compare the light from stars 2 billion years away, 2 billion light years away, that those stars are moving apart slowly compared to the stars who are near us now that seem to be moving apart much faster. But that's because time is moving faster now compared to then. If you're in a faster moving time looking back at a slower moving time, it just appears to you. You can't tell that time is moving slower. Just everything looks like it's slower. But it's actually time. Things are actually moving pretty fast if you're in their time instead of our time. So even though we compare that to what we see close by now and we think the universe is accelerating, it ain't. It was actually moving faster back then, but because we were looking at a slower time, and it has slowed down. The Higgs field causing the attraction to all the matter in the universe, it is slowing down. You just got to take the time dilation. When you're looking back in time, time is slow because the universe is smaller and the Higgs field gets more intense as the universe gets smaller. And that makes me wonder, when you get right down to where the universe was just this big, how slow time. Maybe the Big Bang didn't go if you're looking at the Big Bang from our time here on the planet, it might look like it just happened in slow motion because time was so slow and then time sped up. Now if you were actually inside the Big Bang, inside their time, the time inside the Big Bang, it would happen in an instant. But for our time now, looking back, it would look like it happened in slow motion. And another thing is black holes. Another thing I was thinking about is time is with black holes. Black holes are supposed to be just a speck just a speck. But I know that they have found black holes that are much bigger. They call them more massive black holes. I don't think they're so much more massive. I think a speck can be just as massive as the bigger black hole, because it all comes down to a point eventually. But what happens is the time again, around a black hole especially, time slows way down as you go into a black hole. And so something falling into a black hole, time slows down, and it would probably take the rest of eternity for us to see that from our time, our Earth time, the time on as you approach the center of that black hole. Everything's spinning in there, and it's slowly moving down to this little point. But it's doing it, the time slows down so long that as we observe it, it would take billions of years for that object to actually reach the actual black hole. And but what we actually see is the event horizon. And all of that matter goes down to just a pinpoint, same as the entire universe was at one time. And who knows, maybe the matter, where does it go? I mean, it can compress so far, but you're talking about a singularity, so maybe it converts it into energy, which is what the Higgs field is made of. Maybe it's being regenerated. I don't know. I ain't got it all figured out, but I do got it figured out where the time differentials that happen all over the universe can make everything move, just like we what we relate as gravity. But gravity don't exist. There's only the time differentials. And even an object like standing here on the Earth in one spot, you feel your weight. You feel the Earth pushing back up on your feet there. Your feet is moving in a time that is slightly slower than your head. So your head is actually aging faster than your feet, only by a quintillionth of a second over your lifetime. But these tiny little differences in time emit huge forces, and that's what you feel as gravity. All matter tries to reach the lowest, slowest time. So everything's being drawn to the center. Now, if you could hollow out a place in the center of the Earth and stand right in the dead center, the time dilation would be enough to where if you were standing in the dead center of the Earth, your skin would age faster than your organs inside, because they're farther out than the center. And I'm still talking quintillionths of a second, not enough. You're not going to see wrinkles up here and all that, because there ain't that much mass. Maybe in a black hole. But anyway, those are my ideas. That there is no gravity, there is no space-time fabric, there is not possible to have a wormhole. You can't bend space. Even if they talk about it's not likely to create a wormhole because of the amount of energy it would take to bend space to where it touches each other. Now let's say you did do that, and let's say this is correct, and you bend space to where it touches and you're connected to another part of the universe, clean across the universe. Now you shut off your wormhole. Look at the amount of energy it took to bend space and get it to touch. Now you shut off your wormhole, is space just going to spring back? Where does all that energy come? No, if you was to create that much gravity, yes, you would be in space, and it would touch. The one part of the universe would come together and touch this part of the universe, but it's not going to go back. You just destroyed half the damn universe, and it would take that kind of energy to do. But I don't think you can do that anyway, because I don't think there's a fabric. I don't think there's an actual fabric to space. There's just the Higgs field. And without the Higgs field, atoms fly apart. But so basically, our universe exists of the matter and the Higgs field. And if you tried to go outside that, your atoms would fly apart. So you got to stay inside our universe. But I think the universe may be actually slowing down. This Higgs field may extend billions of miles outside the last piece of matter. I mean, the last star, the last planets at the very, very edge of the universe. The Higgs field may have been eventually moving at like the speed of light, and it's way out there. But I figure it'll all come back in together eventually, and because it's not actually accelerating like they say. So that's it. That's my video. Go ahead and blast me down below. But I think this all actually figures out. If you got any real scientists who can actually do all the heavy math, check it out. So see y'all later.